Hello there, and welcome to lesson 3.4. We are going to be graphing some linear functions today. So let's get started. In today's lesson, you're going to learn to graph equations of horizontal and vertical lines, graph linear equations in standard form using intercepts, and then we'll apply them to some real-life problems. So you will find the practice from 3.4 in your student journal on page 77 and 78. And here we go. So here are your horizontal and vertical lines. First of all, we have the standard form of our linear equation right here, standard form. We talked a little bit in the last few days about the slope-intercept form, but sometimes we have x and y on the same side of the equal sign of the equation and the constant on the right. Okay, what we're going to look at is what happens when, a is equal to 0, or when b is equal to 0, and when it says when a is equal to 0, we have by equals c. You know what? This notation is just a lot of words and a lot of symbols, but let's take a look at the horizontal and vertical. So here's what happens. In a horizontal line right here, the graph of y is equal to b, okay? So a horizontal line, all the y values will be the same. The x value, so here's the y-intercept right there, at 0, comma b, whatever this number is. So when you see y is equal to something like, y is equal to 3, then you know that on the coordinate plane, if you went up, maybe this is this line, right? 1, 2, 3. It's horizontal and it's at 3 everywhere, okay? So in this case, x is equal to 2. So you have, this is the graph of a vertical line. All the values of x are the same. So, here's a comma 0, but then this is x is equal to a, which in this case, if we say x is equal to 2, we just count over 1, 2, and all the values of 2 are right there. So let's try a couple of these. Okay, here is the example from the textbook. So you can see the first one, a, y is equal to 4. So we would find on the y-axis 4, and then we would draw a line horizontally. Sometimes I draw a couple lines or a couple dots, along the 4 just to help me make a straight line. Otherwise, use a straight edge. The next one, x is equal to negative 2. So from the origin, go back to negative 2, and then draw it up, up and down. Here we go. This is where we really wanted to be anyway. Number 1, y is equal to negative 3. So from 0, we would go to the y is equal to negative 3, right here. Okay, like I said, I usually just kind of fill in a couple around there. So I have a better chance. Oh, I cannot draw a straight line to save my life, but you can, because you can use a straight edge. I cannot. All right, x is equal to 2. From the origin, go to x is equal to 2, and that's a point on your vertical line. This is a straight line. All values are equal to 2, no matter what the y is. This is a vertical line, okay? So this should be pretty easy for you. Okay, so let's look at a few more things. Using intercepts. So you can use the fact that 2 points determine a line, and we can graph the y-intercept and the x-intercept. So know that when it's the y-intercept, the x-intercept right here, okay, y is equal to 0. Anywhere on the x-axis, y is equal to 0, okay? So in this equation, if we substitute in a 0 for this y, right, this whole expression disappears. Likewise, for the y-intercept, all x's are equal to 0. So you start at the origin, x was equal to 0, so you have to then go up or down and place a dot, the point on the y-axis. So when you're solving these, to find the y-intercept, you'll substitute in the 0 there and solve for y. So here it kind of is to find the x-intercept, let y be 0, solve for x. To find the y-intercept, let x be 0 and solve for y. So we'll do that. Here we go. So we have 3x plus 4y equals 12. The one thing I cannot show you here is when I'm solving these, and I'll show you in class when we do an example, maybe I can do an example on the board, is that you can like take your finger and kind of cover up the one that you're not solving for. So when you're solving for the x-intercept, you would be then covering up this one, right? This one disappears because 4 times 0 is 0, and you can see that there. So you're really solving the problem, right? If this is 0, you're really solving the problem 3x equals 12, and that's how you get the x-intercept of 4. Remember that this represents the ordered pair of 4, 0, and you can see that here when it's graphed. All right, when we're solving or finding the y-intercept, we're going to let the x-coordinate be equal to 0. So you can see that kind of disappears. So what we're solving for is 4y equals 12, right? We get that right there. Oops. And we know that this is the ordered pair 0, 3, and we could graph it there. So all you need are these 2 points, and then you can draw a straight line through them. So this is kind of nice. We haven't gotten to the point where we're having to take this equation and solve it for y. We could simply keep it in standard form and use the intercepts and draw the graph. So let's see if we can do that. So here is number 3, 4, and 5. Now, it does not ask you to graph these particular ones, all right? So we're going to get to some where we're actually going to be drawing the graph. So I like to kind of organize my work. I kind of like to write, okay, I have the x-intercept, and I have my y-intercept, like this. Okay, you can make like a little t-chart. So when you're doing the x-intercept, this y kind of disappears, 4 times 0, right? So you have 3x plus 4 times 0 equals 12. So you're solving 3x equals 12, dividing by 3, and you get x is equal to 4. And this is the x-intercept, right? It's represented by, because the y was 0, 4, 0. I don't know that they have you put it in as ordered pairs. They might just ask you to tell what the intercept is. For the y-intercept, we make x equal to 0. So 3 times 0 plus your 4y. Now we're going to solve for y. So what we're really solving is 4y is equal to 12. Okay, and y is equal to 3. So the y-intercept equals 3. And that is represented by the ordered pair. Okay, just so you're aware of that, because in the next step, we're going to be graphing these 2 points. All right, so we can just keep going. We can do x-intercept, and at any time, you may pause the video and work ahead, and then, try some of these on your own. So for this, and I'm going to take it a step further, I'm going to say when I'm solving for the x-intercept, the y is 0, so this disappears. I could get to the point where I'm literally just solving that half of an equation, right? If negative x disappears, I'm left with negative 4y. Okay, so I'm solving this. I'm solving this. Oops. So I'll get x is equal to a negative 16, y is equal to a negative 4. So my x-intercept is negative 16. My y-intercept, I know you probably don't have enough room in your book to write all this detail. This is the ordered pair negative 16, 0. This is 0, negative 4. So we're aware of that. All right. Get a lot of noise from my computer today. All right, so when we're doing the x-intercept, we want to solve for x. So the y is substituted as 0. So that becomes 0. So we're solving the equation 5x equals negative 30 divided by 5. So we get negative 6. That's the x-intercept. And so that's negative 6, 0. The y-intercept, x is equal to 0. So that first term disappears and we have negative 2y equals to negative 30. So I'm dividing by negative 2. Y is equal to 15. Remember, that's the y-intercept. And that's what's crossing the y-axis. So that would be the point 0, 15. So hopefully that makes sense. If not, remember to ask for help or send me an email and I'll gladly help you. All right, moving right along. Let's use those intercepts to graph. So I'll kind of like come over here and I'll say, all right, I'm going to do my x-intercept. When I do my x-intercept, y is equal to 0, I'm solving negative 8x is equal to 24. So dividing by negative 8 on both sides. X would then be negative 3. Okay, 24 divided by negative 8. So this is represented by the point negative 3, 0. And my y-intercept right here. So when I'm calculating my y-intercept, remember I'm substituting 0 for the x, and then I'll get 12y equals 24. So hopefully you can do some mental math here, right? We're dividing by 12. Y is equal to 2, and that makes the y-coordinate 2, so the x-coordinate was 0. Now these are the two ordered pairs. So we want to do negative 3, 0, and 0, 2. Remember, I don't go right or left, but I go up here. And I have 2 points that I could then draw a line. Okay, let's try this one. Again, you may pause the video and try this on your own. If we do the x-intercept right here, we're solving 2x equals 4. And hopefully you remember how I got here, because I'm substituting in 0 here. So I'm dividing by 2. X is equal to 2, and that represents the point 2, 0, because I substituted in 0 for this y. When I do the y-intercept, I'm substituting in a 0 for the x, so 2 times 0 is 0. So I get y is equal to 4. That represents the point 0, 4. So I have 2, 0, and 0, 4, and I draw this line. As best I can. I'm sure I made some silly faces on that one because I am not a good line drawer on a graph virtually. Okay, so here we go. Now we will erase this. All right. For this one, we are given some information here. So we have a school band selling sweatshirts and baseball caps to raise $9,000 to attend a band competition. Sweatshirts cost $25 each, baseball caps are $10 each, and here's the equation. So you can see that the X represents the number of sweatshirts sold. Okay, that's what X is. And Y is the number of caps sold. So if we use this equation, we could find the intercepts, but then let's also interpret them. So for the x-intercept, I'll start over here. Okay, for the x-intercept, we know we're going to substitute in 0 for y, so I will solve 25x is equal to 9,000. So when I divide both sides by 25, I get x that is equal to, I believe it was 360. Okay, now this means I have the ordered pair 360, 0. So to interpret the meaning of that is you can sell 360 sweatshirts. sweatshirts. And 0 caps to make your goal. Right? My goal was to earn $9,000. All right. So if we're doing the y-intercept, in this case, x becomes equal to 0. So we are solving 10y is equal to 9,000. So we're dividing both sides by 10. And we're going to get the y-intercept equal to 900. And that represents the ordered pair 0, 900. So we could also sell 0 sweatshirts. And 900 caps to make our goal. Okay? Now, if we want to, if 258 sweatshirts are sold, how many baseball caps are sold? So remember, the sweatshirts are the x. So we would take our original equation and substitute in our 258 plus our 10y, and then we're going to solve for y. Okay? So when I multiply 25 and 258, I got 6,450 plus 10y is equal to 9,000. So I'll subtract from 9,000. And I'll get 10y is equal to, and I believe it was 2,550. You can check my work on the calculator. Okay, and I'm going to divide by 10. And so y would be equal to 255. And what that means is we would sell, if we sold 258 sweatshirts, we would need to sell, or would have sold 255 caps in order to meet our goal of 9,000. Okay? Now, we're going to graph the equation. So basically, we want to come up here and graph these two ordered pairs right here. There's 360 and 0, and this 0 and 900, and then draw the line. So I've kind of already taken the liberty to do that today. And then we want to interpret or find two more possible solutions in the context of the problem. So we can pick, oh, you can't even see the bottom here. But we could pick something like, say we go over here, so this is like 200, right? There it is, there's a point right there. This is a point on that graph, and it means we would have sold 200 sweatshirts and 400 caps. Here's another point, right? 300 and 150. 300 sweatshirts and 150 caps. That would all equal the... So what you could do is, pick a place on your y-axis. Like we could have picked, 100. You could even substitute that into your equation up here. Because x is equal to 100, that'd be 250, and then solve for y just like we did in part B, because those would all be points on the graph. So if you have any questions, make sure to write them down and let me know.